Hello and welcome to my channel. In this video we will be looking at reliability across all methods of investigation, which you need to know for AQA A-level psychology in the subtopic of research methods. I hope you enjoy this video and find it helpful. Let's get started. Reliability refers to the extent to which the results can be consistently reproduced when the research is repeated under the same conditions. It assesses the degree to which a measurement tool produces stable and dependable results when used repeatedly under the same conditions. A reliable measurement is not always valid. The results might be reproducible, but they're not necessarily correct. Internal reliability. Internal reliability refers to the extent to which a measure is consistent, dependable, and stable within itself and across its components. Assessing internal reliability. The split-half method measures the extent to which all parts of the test contribute equally to what is being measured. A test or questionnaire is split into two halves, typically by separating even-numbered items from odd-numbered items, or first-half items from second-half items. Each half is scored separately, and the scores are correlated using a statistical method, usually Pearson's. A high correlation of between 0.7 and 0.9 suggests that the test or questionnaire has good reliability. If the test or questionnaire needed to be lengthened or shortened, then the Spearman-Brown prophecy formula is used to estimate the reliability of a test when its length is changed, e.g., if the number of items needs to be increased or decreased. The formula used is, the predicted reliability of the test after changing its length equals the ratio of the new length of the test multiplied by the original reliability of the test, divided by 1 plus the ratio of the new length of the test minus 1, multiplied by the original reliability of the test. Cronbach's alpha is a statistic that measures the extent to which items in a test or survey measure the same underlying construct by calculating the average inter-item correlations among the test items. The formula used to calculate Cronbach's alpha is the number of items in the test divided by the number of items in the test minus 1, x, 1 minus, stigma, the variance of each individual item divided by the variance of the total test scores. The value of Cronbach's alpha ranges from 0 to 1. A value closer to 1 and above 0.7 indicates high reliability and suggests that all the items are measuring the same underlying construct in a consistent manner. A value closer to 0 indicates low reliability and suggests that the items may not be measuring the same thing. External reliability. External reliability refers to the extent to which a measure is consistent, dependable, and stable over time and across different populations and situations. Assessing external reliability. The test-retest method measures the extent to which items on a test stay consistent over time. The same test is administered to the same group of participants on more than one occasion, with a reasonable time interval between tests and without any intervention or treatment in between. Each participant's scores from the first occasion should then be correlated on a scattergraph with their score from the later occasion, with scores from the first test plotted on one axis and the scores from the second test plotted on the other axis. The strength of the correlation should then be assessed using a Pearson's R-test. The degree of reliability is then determined by comparing the correlation with the statistical table to determine the strength of the correlation coefficient. There should be a strong, positive correlation between the two sets of scores, with researchers generally accepting a 0.8 correlation between the test and the retest. There are several factors that could influence test-retest reliability, including the respondents remembering their answers from their first testing, excessively long and short time intervals in between tests, the stability of the trait being measured, the type of test material used, and time taken to complete the test. Inter-rater observer reliability refers to the extent to which different raters or evaluators agree in assessing a particular phenomenon, behavior, or characteristic. Multiple observers or raters are chosen to independently evaluate the same set of subjects or items. Observers use a standardized set of criteria or a scoring system to assess the subjects, e.g., devising a set of categories and agreeing upon operationalized definitions together. This helps ensure that everyone is using the same guidelines when making their evaluations. Each observer independently rates the same subjects. For instance, they might score behaviors on a scale from 1 to 5 based on their observations. Once the ratings are collected, researchers analyze the data to determine how much agreement there is between the observers. This can be done using various statistical methods including Cohen's kappa, measures agreement between two raters while accounting for the possibility of agreement occurring by chance, and intraclass correlation coefficient, ICC, used when there are more than two raters and assesses the consistency of ratings across multiple observers. The results will yield a reliability score. A score close to 1 indicates high agreement, good reliability, while a score closer to 0 indicates low agreement, poor reliability. Ways of improving reliability include clear and concise questions. Make sure that all questions are straightforward and easy to understand. Avoid ambiguous language that could lead to different interpretations. Standardized instructions. Provide clear instructions on how to complete the questionnaire. This helps ensure that all respondents understand what is expected of them. Pilot testing. Conduct a pilot test of the questionnaire with a small group before full deployment. This allows you to identify any confusing questions and make necessary adjustments. Consistent response scales. Use the same response scale throughout the questionnaire. For example, if you use a Likert scale, e.g., 1 to 5, maintain that format for all relevant questions to avoid confusion. Avoid leading questions. Ensure that questions are neutral and do not lead respondents towards a particular answer. This helps to gather more honest and reliable responses. Use multiple items for constructs. For complex concepts, use multiple questions to measure the same construct. This can provide a more reliable measure of the underlying variable. Training for administrators. If the questionnaire is administered by individuals, ensure they are well trained to maintain consistency in how they present the questions and interact with respondents. Assessing internal consistency. Use statistical measures like Cronbach's alpha to assess the internal consistency of the questionnaire. A higher alpha value indicates better reliability. Regular review and revision. Continuously review and revise the questionnaire based on feedback and data analysis to improve its reliability over time. Structured format. Use a structured interview format where all participants are asked the same set of questions in the same order. This minimizes variability and helps ensure consistency. Clear questions. Formulate clear and concise questions that are easy to understand. Avoid jargon or complex language that could confuse respondents. Standardized instructions. Provide clear instructions to interviewers on how to conduct the interview and how to ask questions. This helps maintain consistency across different interviewers. Training interviewers. Train interviewers thoroughly to ensure they understand the purpose of the interview and how to follow the protocol. This can help reduce biases and variations in how questions are asked. Use of probes. Include follow-up probes that can be used consistently across interviews to clarify answers or explore topics in more depth. This helps ensure that all relevant information is captured. Recording and transcribing. Record interviews, with permission, and transcribe them accurately. This allows for a consistent review of responses and helps reduce errors in data interpretation. Multiple interviewers. If possible, use multiple interviewers to conduct the interviews. This can help identify any biases or inconsistencies in how questions are asked or answered. Pilot testing. Conduct a pilot test of the interview process to identify any issues or areas for improvement before the full study. This can help refine questions and procedures. Feedback mechanism. Implement a feedback mechanism for interviewers to discuss challenges or inconsistencies they encounter, allowing for ongoing improvement. Standardized procedures. Develop a detailed protocol for the experiment that outlines each step clearly. This ensures that every trial is conducted in the same way, minimizing variability. Control variables. Identify and control any extraneous variables that could influence the outcome of the experiment. Keeping these constant helps isolate the effect of the independent variable. Randomization. Use random assignment to allocate subjects to different groups. This helps to eliminate selection bias and ensures that the groups are comparable. Replicates. Conduct multiple trials of the experiment. The more replicates you have, the more reliable your results will be, as this helps to account for random variability. Calibration of equipment. Ensure that all equipment used in the experiment is properly calibrated and functioning correctly. This reduces measurement errors and increases the reliability of the data collected. Blinding. Implement single or double-blind procedures where appropriate. This helps to reduce bias from both participants and experimenters, leading to more reliable outcomes. Clear definitions. Define all variables clearly, including how they will be measured. Consistent definitions help ensure that everyone involved in the experiment interprets the variables the same way. Statistical analysis. Use appropriate statistical methods to analyze the data. This helps in understanding the reliability of the results and in determining if they are statistically significant. Documentation. Keep thorough records of the experimental process, including any deviations from the protocol. This documentation aids in understanding any factors that might have impacted the results. Clear operational definitions. Making sure that behavioral categories have been properly operationalized, are objectively defined and not open to interpretation, and that they are measurable and self-evident. Categories should not overlap, e.g. hugging and cuddling, and all possible behaviors should be covered on the checklist and are not absent. This ensures that everyone involved in the observation understands exactly what to look for. Standardized observation protocol. Develop a standardized procedure for conducting observations. This includes a checklist or a coding scheme that observers can follow to maintain consistency. Training observers and raters. Train all observers and raters thoroughly on the observation criteria and procedures. This helps minimize variability in how different observers interpret and record observations. Use multiple observers. Employ more than one observer to collect data simultaneously. This allows for comparison and helps identify any discrepancies between observers. Inter-observer reliability. Measure the agreement between different observers by calculating inter-observer reliability. This can be done using statistical methods such as Cohen's kappa to assess how consistently observers are recording the same behaviors. Pilot testing. Conduct a pilot study to test the observation protocol before the main study. This can help identify any issues with the observation process that need to be addressed. Repeated observations. Conduct observations multiple times over different periods. This helps to capture a more comprehensive picture and reduces the impact of any anomalies. Environmental control. Try to control the environment in which observations take place. Reducing external factors that could influence behavior helps in obtaining more reliable data. Documentation. Keep detailed records of the observational process, including any contextual factors that might affect the observations. This provides insight into the conditions under which the data was collected. Thank you for watching. If you have enjoyed this video, please like and subscribe for more content like this. Bye.